Alright, before we continue on with graphs of functions, we need to talk about interval notation, because as we start to talk about the different characteristics, we're going to have to represent some of those characteristics in interval notation rather than inequality notation, which is what we've been using for domain and range. So there's several different ways to talk about a set of numbers. So we got inequality notation, which is your number is less than or equal to x is less than or equal to your number, and sometimes this is less than, and sometimes this is infinity or negative infinity, but that's inequality notation. Interval notation takes those same two numbers and puts them in a set of either parentheses, or you may also see it in a set of brackets, and the brackets would look like this, or any combination thereof. So you could have a bracket on one side and a parentheses on the other, or vice versa. The last kind of notation is called set notation. So you see these pretty set symbols, and then it's got your x and this straight line, and then a number and some sort of inequality happening over here, which looks really similar to inequality notation. You read this, and excuse the messing up right there, but this means x such that x is between the first and last numbers that they name. So where you can say x is such that x is greater than. Set notation just really isn't used very often anymore. Alright, we're going to focus on interval notation as we compare it to inequality notation, because inequality notation is what you've been using. So translations, meaning we're going to translate this from inequality to interval. Make sure we're not getting that messed up with graphic translations. Alright, so we're translating from inequality to interval. So when you have a less than or greater than symbol that's not the or equal to parts, you use parentheses on either end. So if this one would be over here, and so on. This is less than or equal to, so when you got the or equal to signs, you got nice straight brackets. So to me, if you have a straight line underneath your symbols, you're going to have straight lines at the top and bottom of your brackets. Alright, and they can be mixed up too. So you could have, for example, when you take x is 2 is less than or equal to x is less than 8. That translates into this bracket going with the 2, and the parentheses, the open parentheses going with the 8. So you put your 2 and your 8, a bracket and a parentheses, and you're done. That's an interval notation at that point. So I've created this chart, and you should have a document that looks similar to this, just not all filled in, but this is the chart that takes you from the number line to the inequality to interval notation, so you have it all in one place and you've seen it before. So when you have like number 1, you've got your open circle and then everything that's less than a, that would be x is less than some number a. We don't know what the number is, but it could represent any number in the whole number line. Alright, so your inequality notation is x is less than a. Your interval notation starts at negative infinity and goes to a. So it's from negative infinity all the way to a. If you're reading it from left to right, it starts as far left as negative infinity and stops at a, but does not include a. So you have an open parenthesis, meaning an open-ended interval here. So the open circle being a parenthesis goes on this end. Infinities always have a parentheses. I always say there ain't no bracket big enough to hold on to an infinity. So they always get parentheses. So the next one down is the same thing. The only change is that B has the dot filled in where A was open. So as the change in inequality notation would take it from x is less than to x is less than or equal to, because that closed dot means it could equal B. So x is less than or equal to B. Your infinity side of it stays exactly the same. It goes all the way to negative infinity. It's always going to be a parentheses. Your B gets a bracket because that's the side on which it's closed. If we're going greater than, C is the lowest number, and it's every x that's bigger than C, so x is greater than C. So we're going to start at C and go all the way to infinity. The circle's not closed. You don't get a bracket. We get a parentheses instead. And the next one's the example of the exact same thing. X is greater than, but now or equal to D. So x is greater than or equal to D. So the only change from here to here, besides the letter, is that we go from parentheses to brackets here. So D is included in there. Then we've got a set of numbers that is in between A and B. So x is going to be some number in between A and B. Well, both circles are open, both are just less than symbols, nothing is a greater or an equal to symbol. So it's just from A to B, and both of them are open, so you got parentheses. The next example is still a span of numbers starting with one number and ending with another, except it's equal to on the low end and not equal to on the high end. So we have C is less than or equal to x, where x is less than D. So C is going to have the bracket, D is going to have the parentheses. Then we've got E going to F. E does not have an equal to sign because it's open, so it has the parentheses. The closed circle gets the or equal to sign and the brackets. So these things all mean the exact same thing. Keep that in mind. Going from G to H where they both equal would put you in brackets on both ends. All real numbers is technically no way to write this in this notation. We may have written before, though, you may have seen us write negative infinity is less than x is less than positive infinity. We've written that for domain. We've started way at negative infinity and gone all the way, but technically this is incorrect. You're not supposed to write this. There's no way to really write it because you're supposed to write your infinity. So here we also may have written negative infinity is less than x is less than a. We might have written that before too. But instead of writing that, there's really no way you're supposed to write it. But that gets us pretty close to what our interval notation looks like. It's a negative infinity on one end and a positive infinity on the other. And still there ain't no bracket big enough. We're using our parentheses instead. So now we're going to try to change from the inequality notation to the interval notation. So here are your three problems. We've got 3 is less than x is less than or equal to 24. X is less than 4. And 5 is greater than or equal to x. So let's see if you can write that from inequality notation and write that as interval notation. So if you pause that and you're kind of struggling, let me show you some examples. Alright, so if we've got this example here of 2 is less than or equal to x is less than infinity, which again, that's how we would have written it when we were describing domain or range. But how it should have been written is just like this. X is greater than or equal to 2. So my 2 is going to have my bracket, and my infinity goes at the end. So if we can think of it in terms of this, even when it's written like that, it will help us write our interval notation. X is less than 3. That means I could almost put in like a less than and a negative infinity sign over here, and I got my negative infinity on one end and my 3 on the other. It wasn't equal to, so I'm just going to leave it as open parentheses. This one spans from negative 7 to 1, open on this end, gets a parentheses, closed on this end, gets a bracket. And I wrote it all in words as well, so x is greater than 2, x is less than 3, x is between negative 7 and 1.